Welcome to our deep dive. Today, we're focusing on a component that you might not think about until the power goes out. We're talking about the backup power for enterprise monitoring systems. And our mission is to pull some really crucial insights from the spec sheet of a single replacement battery.
Exactly. And when you're monitoring these, incredibly sensitive environments, data centers, critical infrastructure reliability is just everything. The specs here, they reveal so much about the cost of failure.
So let's get specific. We're looking at the NTI E-Battery2. It's a sealed, rechargeable lead-acid battery. It's designed for models like the E16D, the E16DEL, and so on. And this small unit protects systems that cost thousands. That's really the core of this, isn't it?
It is.
So what's the key technology here? I mean, what makes it enterprise grade?
Well, it really starts with how it's built. The core is something called absorbent glass mat technology, or AGM.
AGM, right?
And this isn't your standard PAR battery. The electrolyte is held in these fiberglass mats, which makes it, way more resistant to vibration and impact.
Which is critical when it's sitting next to running equipment.
Absolutely. And you see in the specs, it's listed as valve-regulated, maintenance-free, and spill-proof.
Yeah, let's talk about that. Maintenance-free sounds great, but how does that actually work?
It's pretty clever. It uses gas recombination technology. So basically, it prevents gas from escaping, which means you never have to add water. You combine that with a really rugged ABS case, and you've got something that's incredibly safe to put inside a packed equipment rack.
Okay, let's get into the power delivery numbers. The big headline number is 12 volts with a nominal capacity of 2.80 amp hours.
Yeah, but that's the number you have to be careful with. I mean, that's the 20-hour rate.
A very slow discharge rate.
Exactly. It's misleading if you're planning for a real outage. The moment that system needs immediate power, that rated capacity is sort of irrelevant. You can see the trade-off right there in the specs. It drops to 2.50 AH at a 10-hour rate. But if the system really pulls a lot of current, look at this, it plummets to just 1.70 AH at the 1-hour rate.
Wow, that's a huge drop. And I see another spec here. The internal resistance is incredibly low, 60.0 milliohms. Why does that tiny number matter so much?
Oh, it's everything. Low resistance means it can deliver a huge burst of power without losing a bunch of energy as heat. It translates directly to its short duration discharge capacity. It can put out 28.0 amperes for 10 seconds.
And that's the massive surge you need the instant the main power cuts out.
The exact millisecond. That's what you're paying for.
Okay, so what about endurance? How long can you trust this thing once it's just sitting on a shelf? Let's talk shelf life.
Shelf life is a huge deal for anyone managing inventory. At a standard room temperature, 68 degrees Fahrenheit, the capacity decays to 97% after just 1 month.
Okay, not too bad.
But look at 6 months, it drops to 83%. So that spare battery you have sitting there has already lost a significant chunk of its life before you even install it.
That's a critical piece of information for any maintenance schedule.
Right.
And what about once it's deployed? I mean, these can end up in some pretty harsh environments.
For sure. And the operating temperature range really speaks to its robustness. It can charge and discharge reliably from a very cold 15 degrees C all the way up to 50 degrees C.
And even hotter for discharge, right?
Up to 60 degrees for discharge, yeah. It's built for places where a standard battery would just fail.
And one final really important note on maintenance, the compatibility. For the E16D non-UL model, you have to check the serial number label. Make sure the date is either earlier than April 7th, 2020, or later than November 30th, 2021.
A small detail that could save you a huge headache.
So to pull this all together, what this really shows us is that this isn't just a battery. It's an engineered component. It's using AGM tech and really precise capacity engineering to work under stress.
Right. And if you think about the bigger picture here, you have a $78 component protecting a system that costs, almost $1,400? So the real question to think about is this. What does the need for these high-performance specs on a relatively cheap part tell you about the perceived cost of failure? I mean, what is the price of that one moment when the lights go out?